Hello everyone, welcome to the Distilling Insight YouTube channel. So what we just want to talk about today is swords. Swords. Now what are swords? Sword is actually a Latin word which means to be deaf or mute. Deaf and mute. That's what sword really means, a Latin word. Though in the ancient days, sword was actually numbers were being looked as rational, being audible and irrational numbers being inaudible. So as a result, they believe these inaudible numbers are deaf numbers, and that's why it was later now resulted from the Arabic word asam to become sod, which is a Latin word. So basically sod is just like a deaf numbers that cannot be simplified further without having a decimal point or without having a fraction. So what we are saying in essence is this. We are saying a sword is just numbers that does not have a root, direct square root. So when you talk about square root of 4, square root of 8, this is 2, this is 4. Square root of 16 is 8, square root of 9 is 3. But when we're talking about some numbers like this, square root of 6, 6 is a composite number, square root of 20, they do not have a proper square root, unlike this, because these are perfect squares. These are perfect squares. So, but unlike this, they don't have a perfect square. They are not perfect squares, and this means for you to get this, is going to be simplified in this manner for you to have this. If you want to have this, it's going to be simplified in this manner, and you can have it to end this way. So moving forward on sword, what we are saying in essence with respect to sword is numbers that does not directly have the roots. I'll quickly give an itemization of the fact that even though a sword can be represented in an exponential format, sword are being differentiated into 3 different types. So the types of sword, we're having number 1, pure swords. Pure swords. Pure swords. So when you talk about pure swords, it talks about single numbers like square root of 7, square root of 10, something like 3 square root of 8. That's root 3, root 8, third root of 8 rather. So that is pure sword. Now the second type of sword is mixed sword. Mixed sword. So when you talk about mixed swords, you're talking about mixtures like, please note, this is a pure sword. It's written as this. It's different from this. This is the cube root of 8, which will give us 2 as the final answer. This is 3 square root of 8. They are 2 different things. That's why I wrote it clearer. This and this are the same. So I can just write this in order for it to be. So this is the cube root of 8. This is 3 root 8. So this is a mixed sword. What we are saying in essence here is that we are saying something like 8, then square root. Then we are saying square root of 5. This is a mixed sword. The last type of sword is a compound sword. Compound sword. Compound sword. When you talk about compound sword, it's actually sword of two swords that are like a compound. Something like this is a compound sword. Something like this is a compound sword. Something like this is a compound sword. These are compound swords. These are compound swords. So that is that about the types of sword. We have the pure swords, we have the mixed swords, we have the compound swords. So moving forward, going to the sword rules of sword. As it were, one of the basic thing or important things that we always need to note when it comes to sword is that sword can be multiplied, meaning you can have the multiplication of sword as A times B to be equal to A times B. We are saying square root of 2 times square root of 3 equals square root of 2 times 3, and that's square root of 6. And we are saying square root of 6 is still the same as simplifying 2 times 3 and ending up square root times this. So either way is right. That's what we are saying. So you can multiply swords and you can even break it down, the multiplicity that of the value inside the square root or the cube root, whichever root value that you are having. Number one, you can multiply swords. The second is that swords are divisible. This multiplication, then the second, divisibility. Swords are divisible. You can have x over y, meaning this can in turn become this. And in the same vein, you can have this and you end up like this. So that's the second rule of the sword, meaning this square root of x divided by square root of y is the same thing as saying the square root of x divided by y. So you can divide sword. That's the second one. The third is that a sword can be expressed as an exponential. A sword can be expressed as an exponential. So if we're having square root of a, it's still the same thing as saying e raised to power 1 over 2. If we're having the square root of 1 over a, this is the same thing as saying a raised to power minus 1 over 2. The 1 divided by here shows that this is still the same thing as saying square root of a minus 1. So it simply says a raised to power half minus 1. This bracket and this, they are going to multiply each other. Then it's going to give us a raised to power minus half. So you can express a sword as an exponential, just the way we've done the expression here. Now, after that, you need to bear at the back of your mind that it is important to note that when you're talking about swords, in terms of this basic class, number one, you can't add swords as it were. Though you can add similar sword, but you cannot add sword just the way we did for the multiplication and division. When you have something like this, you can't break it down like this. When you have something like this, you can't match them up. It's not possible. It's wrong. Let's quickly do an example of what I've just talked about. 2 plus 3 you can never say, or let's use something that is having a value of 4 plus 5. 4 plus 5 equals 9. Square root of 9 equals 3. Now, if you want to do this again, and you're now separating it at this, equals square root of 4 plus square root of 5. Square root of 4 is 2. What's square root of 5? 2 point something. And as a result, it can never give you 3. So this is not equals to this is not equals to this. So those are the background of surds. Now for us to quickly have a few examples in order to manage our time and not to expand things further. Number 1, reducing surds. So let's quickly speak about reducing surds. Like we're having 18. To reduce this, just look for the perfect number, perfect square that is in here. Then you're having 9 times 2, 3 root 2. Because this is the same thing as saying root 9 times root 2 equals 3 root 2. That's that about that. The second, we are having 80. This 80 here, you know, if you do 4 times 20, you get that. And if you do 16 times 5, you still get the same answer. So you can expand further to be this, right? So you are saying 4 root 5, and that's the answer for that. The second example, before we call it a day on this section of the video to the next video, in order to manage our time, is you can also look for a way to express square roots of a single numbers. Like, look at this question, express the following as the square root of a single number. This question is also an insert question. And what you're saying in essence is you're having 2 square root of 5, then you should express it as a single surd. So what you are doing here is you're saying square root of 2 times square root of 5. Because if you're going to be rooting this can cancel this out. That's why you are squaring this. Then you're having square root of 4 times square root of 5, and that's square root of 20. The same thing applies when we're having something like 5 root 10. This is saying square root times square root of 10. This 25 times 10, and that's 250. So that's just that about that. And when you're talking about addition of surd, which will be the last aspect here before we move to the next class, addition of surd, addition and subtraction of surds. Now when you have questions like this, you remember we've established the fact that you can't add this up directly. You must look for a way to get a common factor that will make them to become like terms. So what is the perfect square that you can get here? That's square root of 4 times 2 plus the perfect square you can get here, 9 times 2. By the time you find the square root of this, it becomes 2 root 2 plus this, that's 3 root 2. Now, the root 2 and root 2 makes this to be like terms, just like if this is 2x plus 3x, then it becomes 5x. It's the same thing, it becomes 5 root 2. This is the way you can add your request. Now, for the last question, which is on subtraction of surds. Subtraction of surd. For subtraction of surd, let's just have this example, 27 minus root 12. The same thing that we did for the previous one. Now, we have 9 times 3 minus 4 times 3. Okay, so 3 root 3 minus 2 root 3. That's 3x minus 2x, so we are going to be having root 3 as our answer. That's if you are just using that as an applicable way. So in order to keep this video short, I'm going to stop here. The next class will continue with multiplication, rationalization, and much more details on sorts. Thank you for joining us on this version, on this class, on this for Distilling Insights video on sorts. Do well to look out for more videos around sorts and other mathematical expressions, while we'll be leveraging on artificial intelligence for subsequent classes in terms of professional training skills. Thank you. Ensure to click the thumbs up button, like, share, and bye bye.